Good afternoon, everyone. I'm Dr. Madhusudan K, Head of the Department for Electronics and Communication Engineering. Today, I'm going to give the brief concept related with the electronic devices. Uh, Whether I'm audible, can you reply in the text box? Yeah, okay. Today, I'm going to cover the concept related with the compare conductor, insulators, and semiconductor with an example. So that is the first topic I am going to cover. After completion of this concept, then I will cover the concept related with the identification of types of value of resistor color codes. Then I will cover the concept related with the PN junction diode, its symbolic representation, characteristic, and type of diodes. After completion of this, I will cover the next concept like rectifier, need of rectification, then how the rectifier works. Then next I will cover the concept related with the transistors. So this is a syllabus I'm going to cover. After this syllabus, the next digital syllabus will be covered by our colleague. So first, if you start with the, if any doubt arises, you can ask the question. ಯಾವ್ದಾದ್ರು doubt ಬಂತಂದ್ರೆ question ಕೇಳಿ. First, if we start with the concept like compare conductor, insulator, and semiconductor. So now here, whenever you take any material, we will classify the material into conductor, insulator, semiconductor. See, conductor means those are the material, they will allow the flow of current. Say, for example, whatever the wires like copper wire, aluminum wire, or gold, these are the conductors. That means they will allow the current to flow without any opposition. And similarly, there is another property called as insulators. Insulators means they are opposed for the flow of current. That means they won't allow any current to flow. And the next another type of material we call it as a semiconductor. So now you can observe nowadays almost all electronic appliances are comes with a concept called as semiconductors. Now whatever you are using the ICs, integrated circuits, or transistors, MOSFETs, all are comes under the semiconductor. Even LED display, LCD display, LED display, all are comes under semiconductor. Now, if you want to understand how this the difference, see here, if you observe, there is a conductor will be looks like this. If I take any material, there are two bands are there. One is we call it as a conduction band, another one we call it as a valence band. In a case of conductor, both the bands are overlapped. That means there is no gap. There is no gap means easily the electrons can flow from one band to another band whenever you apply any potential. Uh, if you observe another type of device like a semiconductor, here there is a small gap is there between the valence band and conduction band. So if I want to make to conduct the current, then I need to apply some voltage. So the gap will be specify how much voltage you need to apply. Here you can observe there is a 1 EV electron volt. That much voltage if you provide, then electrons will flow from the valence band to conduction band. And the last another type of device we call it as a insulators. So insulators means there is a large gap will be there. So wide gap between the conduction band and insulators. So if you observe the examples, then you can easily understand which are those are conductors, which are the semiconductor, which are the insulators. So here the example for the conductors like gold, silver, copper, iron and aluminum. ಏನಂದ್ರೆ ಕಂಡಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ಲಿಕ್ಕೆ ಯಾವುದೇ ಅಪೋಸಿಷನ್ ಇರಲ್ಲ. For example, in your integrated ICs, they will use gold as a connection from one device to another device. It has more purity for the flow of current as compared to copper. ಈಗ ನಾರ್ಮಲ್ ಆಗಿ ನಾವು ಯಾವುದೇ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾರ್ಮಲ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಕಾಪರ್ ವೈರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಒನ್ ಡಿವೈಸ್ ಇಂದ ಇನ್ನೊಂದು ಡಿವೈಸ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ. Still it has some resistance, but gold has less resistance compared with the copper. These are the examples, like example of a good conductors or conductor. So here there is another type of material, we call it as a semiconductor. See, semiconductor means it is constructed by using silicon, germanium, cesium and gallium arsenide. See, if you take any electronic device are constructed by majority of them are semiconductors. ನೀವೀಗ ಯಾವುದೇ IC ಫ್ಯಾಬ್ರಿಕೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಸಿಲಿಕಾನ್ ಬೇಕು. If I want to make any FET or electronic device like transistors or diode, LED, we'll use germanium or gallium arsenide. ಸೊ ಈ ತರ ಡಿಫ್ರೆಂಟ್ ಮೆಟೀರಿಯಲ್ಸ್ ಇದೆ. ಈ ಮೆಟೀರಿಯಲ್ಸ್ನ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್ ಆಗಿ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದೆನ್ ಅನದರ್ ಥಿಂಗ್ ಲೈಕ್ ಇನ್ಸುಲೇಟರ್ಸ್. ಆಸ್ ಐ ಟೋಲ್ಡ್ ದಟ್ ಇನ್ಸುಲೇಟರ್ ವಿಲ್ ಅಪೋಸಸ್ ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್. ಮೇ ಬಿ ನೀವು ಕೇಳಿರ್ಬೋದು, ಯಾರಿಗಾದ್ರೂ ಕರೆಂಟ್ ಶಾಕ್ ಹೊಡಿತಾ ಇದ್ರೆ ಅವ್ರನ್ನ ಬಿಡಿಸ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀವಿ? ವಿಲ್ ಟೇಕ್ ಐದರ್ ರಬ್ಬರ್ ಮೆಟೀರಿಯಲ್ ಇಂದ ಬಿಡಿಸ್ತೀವಿ, ಅಥವಾ ಗ್ಲಾಸು ಅಥವಾ ವುಡ್, ಡ್ರೈ ವುಡ್ ಇಂದ ಬಿಡಿಸ್ತೀವಿ. ಸೊ ನಾವು ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಗ್ಲಾಸ್, ರಬ್ಬರ್, ಪ್ಲಾಸ್ಟಿಕ್, ಡೈಮಂಡ್, ದೀಸ್ ಆರ್ ಆಲ್ ಇನ್ಸುಲೇಟರ್. ದಟ್ ಮೀನ್ಸ್ ದೇ ವೋಂಟ್ ಅಲೋ ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್. ಸೊ that is a 3 different materials are present in a electronic device. Majoritarily we'll go with the using the semiconductor devices. Now we'll proceed to the next. Before proceeding to the next concept, now here in your DCET exam they ask one question: a semiconductor has dash temperature coefficient. So here they given an option like, so it is positive temperature coefficient, 0, negative, constant. So here the answer for this semiconductor has a negative temperature coefficient. Now I would like to tell what you mean by negative temperature coefficient. See, now if I take a response, this is temperature, this one is a resistance. Now if we take for the semiconductor, the temperature coefficient is negative. ನೆಗೆಟಿವ್ ಅಂತಂದ್ರೆ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ರೂಮ್ ಟೆಂಪರೇಚರ್ 30 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದೆ ಅನ್ಕೊಳ್ಳಿ, ಅಂಡ್ ಮೇ ಬಿ ಟೆಂಪರೇಚರ್ ಮೇ ಇನ್ಕ್ರೀಸಸ್ ಟು 35 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್, ಆರ್ ಟೆಂಪರೇಚರ್ ಮೇ ಇನ್ಕ್ರೀಸಸ್ ಟು 40 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. So now here you can observe what is the change you can observe here in this graph. When the temperature initially 30, the resistance value is more. When temperature is 35 degree, the resistance is less compared with the 30 degree. When the resistance value is less at 40 degree compared with the 35 as well as 30 degree. It means that when the temperature increases, its resistance of a semiconductor decreases. So that property we call it as a negative temperature coefficient. So here ಇದರಲ್ಲಿ ಸೆಮಿಕಂಡಕ್ಟರ್ ಪ್ರಾಪರ್ಟಿ ಏನಂದ್ರೆ ಟೆಂಪರೇಚರ್ ಮೇಲೇನೂ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನೋಡಿ, ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್ ಡಿಸೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಟೆಂಪರೇಚರ್ ಮ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಈಗ ಅರ್ತ್ ಮೇಲೆ ಟೆಂಪರೇಚರೇ ಬೇರೆ ಇದೆ, ಈಗ ಮೂನು ಅಥವಾ ಮಾರ್ಸಿಗೆ ಹೋದಾಗ ಅಲ್ಲೇ ಟೆಂಪರೇಚರ್ ಬೇರೆ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಆ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸಸ್ನ ಡಿಸೈನ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇಲ್ಲಿ ನಾವು ಜನರಲ್ ಆಗಿ ಯಾವುದೇ ಸೆಮಿಕಂಡಕ್ಟರು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಇದು ರೆಸಿಸ್ಟಿವಿಟಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಈ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ನೆಗೆಟಿವ್ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್. So now I think that was a one question. Another question asked in your DCET exam is, a hole in a semiconductor is defined as. ಒಂದು ತಿಳ್ಕೋಬೇಕು, ಯಾವುದೇ ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ, ಸೆಮಿಕಂಡಕ್ಟರ್ ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ ಎರಡು ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಇದಾವೆ. ಒನ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ ಈಸ್ ಹೋಲ್, ಅನದರ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. ಒನ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಾನ್, ಅನದರ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ ಈಸ್ ಹೋಲ್. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ನೆಗೆಟಿವ್ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ, ಹೋಲ್ಸ್ ನ ಪಾಸಿಟಿವ್ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. ಇಲ್ಲಿ ಕ್ವಶನ್ ಕೇಳಿರೋದೇನು, ಎ ಹೋಲ್ ಇನ್ ಎ ಸೆಮಿಕಂಡಕ್ಟರ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್. ಸೊ ಜನರಲಿ ಯಾವುದೇ ಆಟಮ್ ತಗೊಂಡ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್, ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡು, ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಇರುತ್ತೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗಡೆ ಹೋದ್ರೆ ದಟ್ ಪಾರ್ಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಹೋಲ್. ಸೊ ಇದಕ್ಕೆ ಆಪ್ಷನ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, ದೇ ಗಿವನ್ 3 ಆಪ್ಷನ್ಸ್, 4 ಆಪ್ಷನ್ಸ್. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಲೈಕ್ ಎ ಫ್ರೀ ಪ್ರೋಟಾನ್, ಫ್ರೀ ನ್ಯೂಟ್ರಾನ್, ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ದ ಇನ್ಕಂಪ್ಲೀಟ್ ಪಾರ್ಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಬಾಂಡ್ ಅಂತ ಸ್ಪೆಸಿಫೈ ಮಾಡಿದ್ದಾರೆ. See, if you take any atom, it has 4 major part. One nucleus, proton, neutron, electrons. So if free electrons, answer for this question is a free electron, it will create the hole in a semiconductor. So that means if any electron move from its band, then it will become a hole. So that scenario we call a hole in a semiconductor is defined as a free electron. This is a concept related with the semiconductor, conductor and insulator. ಏನಾದರೂ ಡೌಟ್ ಇದೆಯಾ? If you do you have any doubt with respect to the whatever the explanation I gave till now? Okay, I think one student is responded no. So now we'll proceed to the next concept. So identification of type and values of resistor color codes. ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಡಿವೈಸಸ್ ಓಪನ್ ಮಾಡಿದ್ರೆ, ಐ ಥಿಂಕ್ you take your in your home only, there are many electronic gadgets are there, like your TV or your remote, your mobile, or even your if you take even refrigerator or washing machine, oven, or all electronic appliances. In electronic appliances you may observe this type of device. This is a device, we call it as a resistors. ಈ ತರ ಕಾಣುವಂಥದ್ದು ಏನು ಫೋಟೋ ಇದೆಯಲ್ಲ, ದಿಸ್ ವಿಲ್ ರೆಪ್ರೆಸೆಂಟ್ ದ ರೆಸಿಸ್ಟರ್ ನ ಫೋಟೋ ಒಂದು. ಸೊ ನೌ ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ದಿಸ್ ರೆಸಿಸ್ಟರ್, ದೇರ್ ಆರ್ ಸಮ್ ಕಲರ್ ಬ್ಯಾಂಡ್ಸ್ ಆರ್ ದೇರ್. ಇಲ್ಲಿ ಬ್ರೌನ್ ಇದೆ, ಬ್ಲಾಕ್ ಕಲರ್ ಇದೆ, ದೇರ್ ಈಸ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಆಸ್ ಬ್ರೌನ್, ಬ್ಲಾಕ್, ಅಂಡ್ ದೇರ್ ಈಸ್ ಎ ಗೋಲ್ಡ್ ಕಲರ್. What it indicates? It indicates the value of this resistance. See, now you can observe resistance main property is opposes the flow of current. So I want to opposes the flow of current, then we'll go use as the resistor. So in this topic, what you will learn, you are going to learn how to find out the value of a resistance by using color codes. ಇಲ್ಲಿ ಏನಂದ್ರೆ, ಈ ರೆಸಿಸ್ಟರ್ ಮೇಲೆ ಇರೋಂಥ ಕಲರ್ ಕೋಡ್ ಬೇಸ್ ಆಗಿ ನಾನು ಇದು ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕಂಡುಹಿಡಿಬೇಕು. ಆ ಕಾನ್ಸೆಪ್ಟ್ ನ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಹಿಯರ್. There is another method is there. By using multimeter also you can measure the resistance. But if I don't have a multimeter, still I want to find out what is the value of resistance. That can be found out by using color codes. Now, how to find out the resistance value of a given resistor by using color code? So here I think this is one of the circuit board. ಇದು ಒಂದು ಪಿಕ್ಚರ್ ಏನಂದ್ರೆ ಒಂದು ಸರ್ಕ್ಯೂಟ್. ಆ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ there are many resistors are there. Here you can observe this is also one resistor. These are the all resistor. Now I need to learn the concept how to find the value of a resistance based on the color code. Now you can observe this is a table. Using this table here, don't worry about these things. You observe only first column, color and digit. So here what they represent, if black is there, that is a value of 0. Brown is there, 1. Red is there means 2. Orange is there means 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9, gold. You can observe this is a tolerance plus or minus 5%, silver plus or minus 10%. If you take any electronic devices, the value what they will manufacture, they don't have exact value. Some minor variation will be there. That is given as a tolerance. ಇದು ಟಾಲರೆನ್ಸ್ ಅಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ನಾನೀಗ 1K 1000 ಓಮ್ ರೆಸಿಸ್ಟರ್ ಮಾಡಬೇಕು ಅಂತ ಇರ್ತೀನಿ. ಬಟ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಮೆಟೀರಿಯಲ್ ಮಿಕ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನಾದರೂ ಮಿಸ್ಟೇಕ್ ಆಯ್ತಂದ್ರೆ ದಟ್ ಎರರ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಟಾಲರೆನ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ಇಂಡಿಕೇಟೆಡ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 5%. ಇಫ್ ಸಿಲ್ವರ್ ಇಸ್ ದೇರ್ ದಟ್ ಈಸ್ ಇಂಡಿಕೇಟ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 10%. ಸೊ ಇದರಲ್ಲಿ ಏನಂದ್ರೆ ಈ ಟೇಬಲ್ ಅಲ್ಲಿ ಇವೆರಡು ಕಾಲಮ್ ನೋಡಿದ್ರೆ something information is there. If black is there, we need to understand 0. Now I have this table, but still I need to know how the value will be calculated. See, if you want to calculate the value, here we have taken one example. So ಇದರಲ್ಲಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ. ಫಸ್ಟಿಗೆ ನಾವು ಯಾವುದೇ ರೆಸಿಸ್ಟೆನ್ಸು ಕೈಯಲ್ಲಿ ಇಟ್ಕೊಂಡಾಗ ಗೋಲ್ಡ್ ಸಿಲ್ವರ್ ಪಾರ್ಟ್ ಬಿಟ್ಟು ಅದರ ನೆಕ್ಸ್ಟ್ ಪ್ರೀವಿಯಸ್ ಪಾರ್ಟ್ ಈ ಕಡೆ ಸೈಡ್ ಇದೆಯಲ್ಲ, ಸಿ ದಿಸ್ ಇಸ್ ಅ tolerance band. Before that tolerance band there are 3 bands are there. ಇಲ್ಲಿ ನೋಡಿ, ಇದು ಒಂದು ಪ್ರಾಕ್ಟಿಕಲ್ ರೆಸಿಸ್ಟರ್ ಅಲ್ಲಿ ಇದು ಗೋಲ್ಡ್, ಅದರ ಆಪೋಸಿಟ್ ಆಗಿರೋದೇನು ಬ್ರೌನ್ ಫಸ್ಟ್ ಇದೆ, ಬ್ಲಾಕ್ ಇದೆ, ಆಮೇಲೆ ಆರೆಂಜ್ ಇದೆ. ಓಕೆ, ದೀಸ್ ಆರ್ ದ ವ್ಯಾಲ್ಯೂಸ್. ಇದ್ರ ಬೇಸ್ ಮೇಲೆ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಅದಕ್ಕೆ ನೋಡಿ, ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಫಸ್ಟ್ ಬ್ಯಾಂಡ್ ರೆಪ್ರೆಸೆಂಟ್ ದ ಫಸ್ಟ್ ಡಿಜಿಟ್, second band represent the second digit, third band represent the multiplier, and the fourth band represent the tolerance. So now here, for example, e case alli, e example alli, in this example there is first band is what? Yellow. What is the value of yellow? Yellow is 4. So now we can observe first digit will become 4. E first digit na il 4 anta bardidi value ಕಂಡುಹಿಡಿಯಬೇಕಾದ್ರೆ. Next, second band ಏನಿದೆ? What is the second band? Second band is a violet. Okay, so violet, here you can observe this is a violet. What is the value of violet? 7. So ಅದಕ್ಕೆ second band ಅಲ್ಲಿ this is a second digit ಆಗಿ 7 ಬರ್ದಿದ್ದೀವಿ. Then what is the third band? It's there in the resistor. It is a multiplier. So that multiplier, what is the factor multiplier here? It is red. Red ಅಂದ್ರೇನು? 2 ಅಂದ್ರೆ 100 1000 ನ 100 ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಸೊ ಈಗ ಅದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ದೇರ್ ಇಸ್ ಎ ಟಾಲರೆನ್ಸ್ ಬ್ಯಾಂಡ್. ಟಾಲರೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಹಿಯರ್ ವಾಟ್ ವಿ ಅಬ್ಸರ್ವ್, ಇಟ್ ಈಸ್ ಎ ಗೋಲ್ಡ್. ಗೋಲ್ಡ್ ಟಾಲರೆನ್ಸ್ ಈಸ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 5%. ಸೊ ದಟ್ಸ್ ವೈ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 5%. ಇದಿಷ್ಟು ಕಂಪ್ಲೀಟ್ ವ್ಯಾಲ್ಯೂ ಇಫ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್, ವಾಟ್ ವಿಲ್ ಗೆಟ್? 47 into 100 will get 4700 plus or minus 5%. So the value of resistance what we are calculating, its value is 4700 plus or minus 5%. 4700 plus or minus 5% means 4700, its value is not exactly 4700 because plus or minus 5% is there. Now its value ranges from 4465 ಕಡಿಮೆ ಆಗಿರ್ಬೋದು ಅಥವಾ 4935 ಆಗಿರ್ಬೋದು. ದಟ್ ಈಸ್ ಅ ರೇಂಜ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ವೇ ವಿ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ resistance value. Did you understood the explanation what I gave to find out the value of a resistance when the color code is given? ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ, ನಾನು ಮತ್ತೆ ಕನ್ನಡದಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. Okay, now we can observe this is a way we'll find out the resistance value based on the color code. Now we'll proceed to the next topic. So this is a fundamental device, what we call it as a diode. In your syllabus, they specified that PN junction diode symbol, its characteristic, diode as a switch, type of diode, and rating application. First I would like to explain what is PN junction. See, PN junction means P-type material and N-type material. Now you may had a question, what is P-type material, what is N-type material? So I told that in semiconductor, we will create some material, something called as P-type of semiconductor. Another one we call it as a N-type of semiconductor. P-type of semiconductor means here the holes are the majority charge carriers. ಅಂದ್ರೆ ಪಿ ಟೈಪ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಹೋಲ್ಸ್ ಜಾಸ್ತಿ ಇರ್ತವೆ. ಎನ್ ಟೈಪ್ ಆಫ್ ಸೆಮಿಕಂಡಕ್ಟರ್ here the majority charge carriers are the electrons. So that means in n type semiconductor ಅಲ್ಲಿ electrons majority charge carriers ಇರ್ತವೆ. If holes are majority charge carriers means we call it as a positive type of semiconductor. Positive. Electrons ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ negative. Okay, now you can observe in this diagram also. So here this is a P region, P type of semiconductor. If you observe here, there is a positive, it is represented. Whereas next you can observe there is a N type of semiconductor. Here negative is represented. So generally PN junction ಅಂದ್ರೆ ಒಂದು P material ಇರುತ್ತೆ ಮತ್ತೆ N type of semiconductor. ಇವೆರಡು ಕಂಬೈನ್ ಮಾಡಿದ್ರೆ P material and N material, that will become a diode. So ಈ ಕಂಬೈನ್ ಮಾಡಬೇಕಾದ್ರೆ here majority charge carriers are plus holes in the P type material, whereas in the N type of material electrons are the majority charge carrier, that means negative. We know that according to the principle, positive charge will attract the negative. So that means ಇಲ್ಲಿ ಏನು ಕಂಬೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಅಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ. So this will create something called as, there is a what we call it as a junction, PN junction. ಈ ಪಾರ್ಟ್ ಏನಿದೆಯಲ್ಲ, this part we call it as a PN junction. When you combine different material, P material with the N material, it create a junction. So this one we call it as a barrier. Okay, PN junction or a barrier. So this is a construction internally what the diode contains. Now here if you observe, practically diode will be look like this. ಇದರಲ್ಲಿ ಏನಂದ್ರೆ two terminals ಇದೆ, ಒಂದು anode, another terminal is cathode. How we'll find out whether it is a anode terminal or cathode terminal? ಇಲ್ಲಿ ನೋಡಿ ಸಿಲ್ವರ್ ಕಲರ್ ರಿಂಗ್ ಇದೆಯಲ್ಲ, this silver color ring, near to silver color ring, what is a terminal is there, we call it as a negative terminal or cathode terminal. Whereas opposite, another terminal, we call it as a anode terminal. See here, this is also representation of a, this is a PN diode and anode terminal and cathode terminal. This one is a practically what the you are going to observe the PN diode. Whereas this one is the symbolic representation. Now ಯಾವುದೇ ಸರ್ಕ್ಯೂಟ್ ಬರಿಬೇಕಾದ್ರೆ we won't write this actual PN diodes, we'll write the symbols. So in your circuit we'll use this symbol. If I use this symbol in your circuit, we call it as a diode. So in that diode, the positive terminal we call it as an anode and negative terminal we call it as a cathode. So this is a symbolic representation, and the diode contains consisting of or constructed by using two material, P-type material and N-type material. Now you would like to understand its characteristic and diode as a switch. So what is the main use of diode in electronic appliances? See, for example, if I take this is a just now I told the concept related with the PN diode. If I want to understand how I can use PN diode as a switch, see now switch means what? Sometimes I want to allow the current to flow. Sometimes I don't want to allow the flow of current. ಈಗ ನಾರ್ಮಲ್ ಆಗಿ ಮನೆಯಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಸ್ವಿಚ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಿ ಲೈಟ್ ಆನ್ ಆಗುತ್ತೆ. ನಾನು ಸ್ವಿಚ್ ಆಫ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. ಬ್ಲಾಕ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಲೈಟ್ ಆನ್ ಆಗಲ್ಲ. ಸೇಮ್ ಪ್ರಿನ್ಸಿಪಲ್ ವಿಲ್ ಬಿ ಯೂಸ್ಡ್ ಇನ್ ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಅಪ್ಲಯನ್ಸಸ್ by using diode. ನಾನು ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಅಲ್ಲಿ ನೀವು ಮ್ಯಾನ್ಯುವಲ್ ಸ್ವಿಚ್ ಯೂಸ್ ಮಾಡೋ ಬದಲೇ ಡಯೋಡ್ ಸ್ವಿಚ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸಿ ನಾವು ಹೌ ಇಟ್ ವರ್ಕ್ಸ್. ಸೊ there is something called as PN junction diode under forward bias. See, there are two situations are there. One we call it as a forward bias, another one we call it as a reverse bias. Now I would like to tell what you mean by forward bias. Forward bias ಅಂದ್ರೇನು, reverse bias ಅಂದ್ರೇನು? ಈಗ forward bias means when positive terminal of battery or supply source, see, positive terminal of battery is connected to anode terminal of a diode or P type of material diode, P type material terminal. Negative of battery is connected to negative. Here you observe the symbol. This is a symbolic representation of diode. ಈ ಟರ್ಮಿನಲ್ ನ ಆನೋಡ್ ಅಥವಾ ಪಾಸಿಟಿವ್ ಅಂತೀವಿ, ಈ ಟರ್ಮಿನಲ್ ನ ಕ್ಯಾಥೋಡ್ ಅಥವಾ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಅಂತೀವಿ. ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಆಗಿ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಆದ್ರೆ ಆ ಸಿನಾರಿಯೋ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್. ಅದೇ ರಿವರ್ಸ್ ಆಯ್ತು ಅನ್ಕೊಳ್ಳಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಶೋ. ದಿಸ್ ಇಸ್ ಅ ರಿವರ್ಸ್ ಬಯಾಸ್. ರಿವರ್ಸ್ ಬಯಾಸ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ಡಯೋಡ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ನೆಗೆಟಿವ್ ಆಫ್ ಬ್ಯಾಟರಿ and negative terminal of diode is connected to positive of battery. That scenario we call it as a reverse bias. Now it is similar to switch on condition, switch off condition. See, switch on condition means it is forward bias. Switch off condition means it is a reverse bias. Now here what is going to happen? Just now I told that forward bias means positive of battery is connected to anode or positive terminal of diode and negative of battery is connected to negative terminal of a diode. ಇದರಲ್ಲಿ ಏನಂದ್ರೆ ಬ್ಯಾಟರಿ ಪಾಸಿಟಿವ್ ನ ಡಯೋಡ್ ಪಾಸಿಟಿವ್ ಕನೆಕ್ಟ್ ಮಾಡೋದು, ಬ್ಯಾಟರಿ ನೆಗೆಟಿವ್ ನ ಡಯೋಡ್ ನೆಗೆಟಿವ್ ಕನೆಕ್ಟ್ ಮಾಡೋದು. ಅದನ್ನೇ ಇಲ್ಲಿ ಇಂಟರ್ನಲ್ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಟ್ಟಿರೋದು. ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಹತ್ರ ಏನಿರುತ್ತೆ, ಮೆಟೀರಿಯಲ್ ಪಿ ಮೆಟೀರಿಯಲ್ ಇರುತ್ತೆ. ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ಡಯೋಡ್ ಹತ್ರ ಯಾವ ಮೆಟೀರಿಯಲ್ ಇರುತ್ತೆ, ಎನ್ ಮೆಟೀರಿಯಲ್ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಅ ರೆಪ್ರೆಸೆಂಟೇಷನ್. ಈ ತರ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ವೆನ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್, ಬ್ಯಾಟರಿ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್, ಇಟ್ ಈಸ್ ಎ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. ಈ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ಗೆ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡಕ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ವಾಟ್ ಎವರ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ದೇರ್, ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಇಸ್ ಅ ಹೋಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್, ದಿಸ್ ಇಸ್ ಅ ಎಲೆಕ್ಟ್ರಾನ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್. ಇದರಲ್ಲಿ ನೋಡಿ ಪಿ ಟೈಪ್ ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ, ಹೋಲ್ಸ್ ಜಾಸ್ತಿ ಇದೆ, 6 ಇದೆ. ಅದೇ ಎನ್ ಟೈಪ್ ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ ಏನಿದೆ, ಟೋಟಲಿ 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಹೋಲ್ಸ್ 2 ಇದೆ. ಈಗೇನಾಗುತ್ತೆ, ಯಾವ್ದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆಯಲ್ಲ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಏನ್ ಮಾಡುತ್ತೆ, ಪಾಸಿಟಿವ್ ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡುತ್ತೆ. ಈ ತರ ಅಟ್ರಾಕ್ಟ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಜಂಕ್ಷನ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಬೋತ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂಡ್ ನಂಬರ್ ಆಫ್ ಹೋಲ್ಸ್ ಆರ್ ಸೇಮ್. ಇದು ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಇದು ಬ್ರೇಕ್ ಆಯ್ತಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಈ ಬ್ಯಾರಿಯರ್ ಏನಿರುತ್ತಲ್ಲ ಇದು ಬ್ರೇಕ್ ಆಯ್ತಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಕರೆಂಟ್ ಫ್ಲೋ ಆಯ್ತಂದ್ರೆ ಏನಾಯ್ತು, ಆನ್ ಆಯ್ತು, ಸ್ವಿಚ್ ಈಸ್ ಇನ್ ಆನ್ ಕಂಡೀಷನ್. ನಾವು ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಅನದರ್ ಸಿನಾರಿಯೋ ಲೈಕ್ ನೆಗೆಟಿವ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ಪಾಸಿಟಿವ್, ಎಲ್ಲ ಹೋಲ್ಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಆಮೇಲೆ ಪಾಸಿಟಿವ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ನೆಗೆಟಿವ್, ದಿಸ್ ಇಸ್ ಅ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಕಮ್ಸ್. ಈಗೇನಾಗುತ್ತೆ, ಈ ಬ್ಯಾರಿಯರ್ ಇದೆಯಲ್ಲ ಇನ್ನೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ವೈಡ್ ಆಗುತ್ತೆ. ಬ್ಯಾರಿಯರ್ ಜಾಸ್ತಿ ಆಯ್ತಂದ್ರೆ ಇಟ್ ಆಪೋಸಸ್ ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್. ಇನ್ ರಿವರ್ಸ್ ಬಯಾಸ್ the PN junction diode acts as a off condition. In forward bias, PN junction acts as a switch on condition. So e concept na we can represent it with a graph also. So generally we'll write the graph like this. We call it as a VI characteristic of a diode. VI means voltage and current characteristic of a diode. See, this is a part, it is represented with the forward bias. E part na illi hakirodu. The negative reverse bias condition ಇದೆಯಲ್ಲ, this is represented here. What you can able to understand from this graph, ಏನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬಹುದು ಈ ಗ್ರಾಫ್ ಇಂದ ಅಂದ್ರೆ, ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಕೊಟ್ರೆ ದ ಡಯೋಡ್ ಸ್ವಿಚ್ ಆನ್ ಆಗುತ್ತೆ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಲ್ಲಿ, ನಾನು ಎಷ್ಟೇ ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟರು ಡಯೋಡ್ ಆನ್ ಆಗಲ್ಲ. ಆ ಪ್ರಾಪರ್ಟಿನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂತೀವಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಇಂದ. ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಲ್ಲಿ ನೋಡಿ ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀನಿ. ಒನ್ಸ್ ಇಟ್ ಕ್ರಾಸಸ್ 0.7 ವೋಲ್ಟ್ ಫಾರ್ ದ ಸಿಲಿಕಾನ್ ಅಥವಾ 690 ಮಿಲಿ ವೋಲ್ಟ್ಸ್ ಫಾರ್ ದ ಸಿಲಿಕಾನ್, ಡಯೋಡ್ ಆನ್ ಆಗಿಬಿಡುತ್ತೆ. ಈ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಏನಿರುತ್ತಲ್ಲ 0.7 ವೋಲ್ಟ್ ಕೊಟ್ಟಂದ್ರೆ ಡಯೋಡ್ ಆನ್ ಆಗುತ್ತೆ. ಅದೇ ರಿವರ್ಸ್ ಬಯಾಸ್ ಅಲ್ಲಿ ನೋಡಿ, ಇಫ್ ಯು ಗಿವ್ ಇವನ್ ಮೋರ್ ವೋಲ್ಟೇಜ್ ಆಲ್ಸೋ, ಡಯೋಡ್ ವಿಲ್ ನಾಟ್ ಬಿ ಆನ್ ಕಂಡೀಷನ್. So that is the understanding from the PN junction diode can be used as a switch. During the forward bias, it is switch on condition. During the reverse bias, switch off condition. Now here there are different type of semiconductor diodes are there. So now in the present market we are using LED. LED is nothing but light emitting diode. This is also one type of diode. And Zener diode, rectifier diode, tunnel diode, variable capacitance diode, photodiode, switching diode, gun diode. ಈಗ ನಾರ್ಮಲ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ತೀನಿ ನೋಡಿ. ಸಿ ವಾಟ್ ಆರ್ ದ ಅಪ್ಲಿಕೇಶನ್ ವಿಲ್ ಯೂಸ್. ಸಿ ಇಫ್ ಯು ಟೇಕ್ light emitting diode, I think everyone know light emitting diode. Wherever the LED lights are used, all LED lights or LED bulbs are constructed by using the diodes. ಈಗ LED ಡಿಸ್ಪ್ಲೇ ಇರುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಏರ್ಪೋರ್ಟ್, ರೈಲ್ವೆ ಸ್ಟೇಷನ್, ಅದರಲ್ಲೆಲ್ಲ ಮೆಸೇಜ್ ಸ್ಕ್ರೋಲ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ಲ, ಆ ಸ್ಕ್ರೋಲ್ ಆಗೋಂಥ ಕಂಪ್ಲೀಟ್ ಡಿಸ್ಪ್ಲೇನ ದೇ ವಿಲ್ ಕನ್ಸ್ಟ್ರಕ್ಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ LED. ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಮತ್ತೆ ಈಗ ರೆಕ್ಟಿಫೈಯರ್ ಡಯೋಡ್ ಅಂದ್ರೆ ನಾವು ಯು ಆರ್ ಯೂಸಿಂಗ್ ಎ ಮೊಬೈಲ್ ಚಾರ್ಜರ್ ಅಲ್ಲಿ ಮನೆಗೆ ಬರುವಂತ ಸಪ್ಲೈ AC, ಬಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸಸ್ಗೆ ಬೇಕಾಗಿರೋದು DC ಪವರ್ ಸಪ್ಲೈ. AC ಪವರ್ ಸಪ್ಲೈ ಇಂದ DC ಪವರ್ ಸಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ವಿಲ್ ಯೂಸ್ ಒನ್ ಟೈಪ್ ಆಫ್ ಡಯೋಡ್ಸ್. ದೋಸ್ ಡಯೋಡ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ರೆಕ್ಟಿಫೈಯರ್ ಡಯೋಡ್. ಅಂಡ್ ದೆರ್ ಈಸ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಆಸ್ ಫೋಟೋಡಯೋಡ್ಸ್ ಅಂದ್ರೆ ಅದ್ರ ಮೇಲೆ ಲೈಟ್ ಬಿದ್ರೆ ಆನ್ ಆಗುತ್ತೆ, ಲೈಟ್ ಬಿದ್ದಿಲ್ಲ ಅಂದ್ರೆ ಆಫ್ ಆಗುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಈಗ ಆಟೋಮೇಟೆಡ್ ಲೈಟ್ ಆನ್ ಆಫ್ ಅಂತ ಮನೆಯಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಲೈಟ್ ಅಂದ್ರೆ ಸನ್ ಲೈಟ್ ಕಡಿಮೆ ಆದ್ರೆ ಈ ಬಲ್ಬ್ ಆನ್ ಆಗಂಗ್ ಮಾಡಿರ್ತಾರೆ, ಆ ಪ್ರಾಪರ್ಟಿ ಮೇಲೆ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ಸೆನ್ಸಿಟಿವಿಟಿ ಲೈಟ್ ಇದೆಯೋ ಇಲ್ಲ, ಅಥವಾ ಈಗ ನೀವು ಯಾವುದೇ ಒಂದು ಶಾಪಿಂಗ್ ಮಾಲಿಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ before entering to the shopping mall, if you come nearer to door, immediately door will open. There is a some diode, obstacle detection diode irutte, adu identify ಮಾಡುತ್ತೆ. See now you can observe these are the application with respect to the semiconductor diode. We will use other diodes also, variable capacitance diode, tunnel diode, Zener diodes. Zener diode elli use ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we'll use it in what we call it as stabilizers. Whatever in your home appliances, we'll use a stabilizer. I need constant voltage, constant current. Our time alli Zener diodes use ಮಾಡ್ತೀವಿ. And see now you can observe Zener diode are used for the stabilization of current and voltage in electronics system. These are the some of the application with respect to diodes. Now we'll proceed with one question in your DCT. There is an LED. They gave some options like emits light when reverse bias, emits light when forward bias, senses light when reverse bias, acts as a variable resistor. The answer for this question is emits light when forward bias. Light emitting diode, light will emits when it is forward bias. Forward bias means anode terminal of diode is connected to positive of capacitor, and negative of diode is connected to negative of battery. So that condition we call it as a forward bias. So during that situation only the light will emits. And so now you can observe, I think everyone observed LEDs. ನಿಮ್ಮ ಮನೆಯಲ್ಲಾದ್ರೂ ಅಥವಾ ಡಿಸ್ಪ್ಲೇ ಅಲ್ಲಿ ಈ ತರ LED ಇರುತ್ತೆ. To represent this LED in electronic circuit, we use this is a symbol. So what is the difference? If it looks like a diode only, but there is a arrow mark is there, outward arrow. This arrow mark indicate that is a LED, light emitting diode. So now here the light emitting diode also constructed by using P-type material and N-type semiconductor. but light will emit based on what type of material they use. ಈ ಪಿ ಟೈಪ್ ಎನ್ ಟೈಪ್ ಮೆಟೀರಿಯಲ್ ಇದೆಯಲ್ಲ, ದೇರ್ ಇಸ್ ಸಮಥಿಂಗ್ ಬೋರಾನ್, ಆ ಥರ ಯೂಸ್ ಮಾಡಿದಾಗ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಯೂಸಿಂಗ್ ಸಿಲಿಕಾನ್, ಬೋರಾನ್ ಆ ಥರ ಯೂಸ್ ಮಾಡಿ ಇಟ್ ವಿಲ್ ಎಮಿಟ್ಸ್ ದ ಲೈಟ್. ಆ ಥರ ಮೆಟೀರಿಯಲ್ ಯೂಸ್ ಮಾಡಿ ಡಯೋಡ್ನ LED ಮಾಡಿರ್ತಾರೆ. ನಾವು ವಿಲ್ ಪ್ರೊಸೀಡ್ ವಿತ್ ದ next concept, something called as rectifiers. Generally rectifiers are major application in your mobile charger or laptop charger. What you are using, that complete charger will be constructed using designed by using rectifier circuits only. Now you are going to learn what is the need of rectifier and need of AC to DC conversion. Then you are going to learn the bridge rectifier with capacitor, without capacitor. First I would like to tell what is rectifier. A rectifier is a circuit which converts AC to DC. Then what is the need of AC to DC? All your electronic appliances ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ integrated circuit ಇರುತ್ತೆ, or IC will be there. That IC will be works only with the DC power supply, not with the AC. Now I need to convert AC power supply to DC power supply, means I need rectifier. And this rectifier will be constructed by using something called as bridge rectifier. So this is a circuit diagram of a bridge rectifier. ಇದೇನಿದೆ ಸರ್ಕ್ಯೂಟ್ ಇದೆಯಲ್ಲ, this circuit is a bridge rectifier. So here in your appliances means ಮನೆಗೆ AC ಪವರ್ ಸಪ್ಲೈ ಬರುತ್ತಲ್ಲ, ಅದನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ, ಮೊದಲಿಗೆ ವೋಲ್ಟೇಜ್ ನ ರೆಡ್ಯೂಸ್ ಮಾಡಲಿಕ್ಕೆ ಸ್ಟೆಪ್ ಡೌನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ then we will have this rectifier circuit. So in this rectifier circuit there are 4 diodes are there, D1, D2, D3, D4. Now you can observe, now it works like a switch. Diode acts as a switch in this circuit. Now I'll explain during the forward bias how which diode will be on condition. During the reverse bias, which diode will be in on condition. So first, this is a AC supply you are giving. AC power supply, once you give, the voltage will be reduced by this step down transformer. Once the voltage is reduced, so now here you can observe in this case, first case if you observe, ಇಲ್ಲಿ positive cycle ಕೊಟ್ಟಾಗ this is a positive cycle. Once I give positive cycle, this terminal will be acts like a plus, this terminal acts as a negative. Then the D1 diode, now you can observe the positive of D1 diode is connected to positive, that means this is forward bias. And similarly D3 diode, positive is connected to the positive power supply. D1 D3 diode on ಆಗುತ್ತೆ. So once D1 D3 on, remaining D2 D4 will be reverse bias, that is in off condition. Now what happens, the current will flow like this, the arrow mark indicating the flow of current. So the current will flow through the D1 RL, then D3, then it will come back to negative. This is a continuously, it will flow like this. So this will create a waveform like this. Only positive cycle will get across the load. So here load is nothing but your mobile charger ಮತ್ತೆ mobile it acts as a load. Next case scenario ಅಲ್ಲಿ negative supply ಕೊಟ್ರೆ, during the negative supply, that is positive cycle, negative cycle. Once I apply negative cycle, here negative, this will become a negative, and negative is connected to negative of diode and positive is connected to positive. This scenario we call it as a forward bias. Illi aste. So D2 D4 will become forward bias. During the negative off cycle, D2 and D4 will be in on condition, D1 and D2 D3 will be in off condition. Now we'll get a negative off cycle. Negative off cycle we'll get like this. So these this is the way the rectifier circuit works. So if you take the AC supply, so during the positive off cycle, D1 D3 will be on, ee thara waveform barutte. During the negative off cycle, you will get 0, and here we'll get positive. When you take a DC output waveform during the D2 and D4 on, that is reverse bias condition. So you'll get a waveform like this. If you add these two waveform, you'll get, this is a, what we call it as rippled DC. That means in this waveform, there is a combination of AC as well as DC. Now, for your electronic appliances, we don't want AC content. We want pure DC. If you want to get a pure DC, what we'll use something called as capacitor. In this circuit, you can observe there is no capacitor, only resistor is there. So now you can observe, I'm introducing one capacitor. Now, if I introduce a capacitor, what is the task of capacitor? Capacitor property ಏನಂದ್ರೆ it allow AC, it block DC. ಅಂದ್ರೆ AC ಕರೆಂಟ್ ನ ಅಲೋ ಮಾಡುತ್ತೆ, DC ಕರೆಂಟ್ ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. ಇಲ್ಲೇನು ನಮಗೆ I don't want AC, I want DC only. Now what happens? Whatever the AC current will come, it will go to the ground. It will go to transformer, and to the load only will get DC. So in this point, see here, at this point, we'll get only positive, that is DC, straight line. Whatever the negative supply is there, that will go through the capacitor and it will go to the transformer one end. ನನಗೆ ಮೊಬೈಲಿಗೆ ಬೇಕಾಗಿರೋದು ಓನ್ಲಿ DC ಸಪ್ಲೈ. DC ಮೀನ್ಸ್ ಸ್ಟ್ರೈಟ್ ಲೈನ್, AC ಮೀನ್ಸ್ ಈ ಥರ ಆಲ್ಟರ್ನೇಟ್ ಆಗ್ತಾ ಇರೋದು, ಕರೆಂಟ್ನ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದು, ಪಾಸಿಟಿವ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ವಿ ಕಾಲ್ AC. If we have a straight constant voltage, constant current, we call it as a DC. So for electronic appliances, we want constant voltage. So that can be achieved by introducing a capacitor in the circuit. This is a circuit will be used in your mobile chargers. I think here you can observe, we can get the output. So whatever the output you will get, initially you will apply AC current and we'll try to get the pure DC. So when you introduce a capacitor, we'll get a DC. Still in this waveform, we have a ripple. That means we have waveform like this. Actually, my expected waveform will be straight line. Now still I want to remove the AC content, means once again we'll increase the capacitance. If you increase the capacitance, you will get a pure DC waveform. So now what you understood from this session is like when you take a rectifier circuit, here you understood if I want to convert AC to DC means rectifier circuit is required. The main purpose of rectifier circuit is all electronic appliances is work with the DC power supply. And another thing here I explained with the bridge rectifier. Bridge andre I'm using 4 diodes as a switch. During forward bias, positive off cycle, some diode acts as a on condition. During the negative cycle, some diodes are acts as a on condition. And now we can observe this is a one of the IC, ready-made IC is used as a rectifier. In your advanced charger, we will use this type of IC. Instead of constructing a diode by using 4 diodes, they will, in this IC only the 4 diode will come internally. There is a package. So that is KBL04. So this is a rectifier. Now we can observe 4 diode symbol, 1, 2, 3, 4, like that we'll use. Next we'll proceed to the next topic, like last topic, something called as transistor symbol. It's a symbol, structure and working principle. Now you can observe in the diode we constructed the transistor also, it is a semiconductor device. Here transistor consisting of constructed by using 3 material, either P material, N material and P material. This type of construction we call it as a PNP transistor. Or there is another way also we can construct. We can construct like this: N material, P material and N material. So this one we call it as a NPN transistor. Generally, there are two type of transistors are there. One is PNP transistor, another one is NPN transistor. In this transistor, there are three terminals. One is collector, another one is the base, collector, base, and emitter. This is the internal structure of a PNP transistor. Same thing I can represent it with a symbol. This is a symbolic representation of a transistor. Now we can observe collector terminal, base terminal, emitter terminal. And if we observe the second one, that is NPN transistor, here also collector, base, emitter. Now what is the difference in the representation of PNP transistor and NPN transistor? PNP transistor, the arrow is upward. This type of symbolic representation we call it as a PNP. The downward representation of arrow, this one we call it as a NPN transistor. ಈ arrow mark ಇದೆಯಲ್ಲ ಸಿಂಬಲ್ ಅಲ್ಲಿ ಈ ತರ ಇನ್ವರ್ಡ್ ಇತ್ತಂದ್ರೆ that we call it as a PNP transistor. If arrow is outward, ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದ್ರೆ that we call it as a NPN transistor. Generally, majority of application will use the NPN transistor. PNP also will use, but majorly we will use the NPN transistor. Now, if we take, just now I covered what is transistor, symbolic representation, and structure. Structure means, here I am taking one example like NPN transistor. We know that in the N transistor, N material, electrons are the majority charge carrier. In the P material, holes are the majority charge carrier. And in the N material, electrons are the majority charge carrier. Now, once you connect, there is a battery. So here you can observe I am using two batteries. Negative is connected to emitter terminal and positive is connected to base. And similarly, positive of this battery is connected to collector terminal and negative is connected to base. Now here what happens? Negative is connected to negative means the electron will start move from negative will opposes the electrons. Positive will attract the electrons. In negative connected to negative means opposition. That's why you can observe electrons are started moving this side. Now all the electrons will try to move from this end to this end. So at that time, the opposite to the flow of electron, we call it as a current flow. So now whatever the flow of current electrons is there, no, that opposite direction is the current flow. So here if electrons are moved in this direction means current will move in this direction. Now we can observe current direction. This is a IC, IE, IB. These are the current direction. Now, what is the main use of this transistor? Now, generally, transistor will be used in the application like amplifiers. There are two property of transistor is there. One is transistor can be used as an amplifier. Transistor can be used as a switch, controlled switch. That means there is a one terminal, base acts as a control. Generally, we call transistors are the current control devices. So if I give base current, the transistor will be on condition. Major audio amplifiers, whatever the audio amplifier you'll use, in that audio amplifier, the amplifiers are constructed by using a transistors. And even if you take some switches, also constructed by using the transistor. So this is an explanation with respect to transistor symbol and its working principle. There was one question in your DCT exam with respect to transistor. In a transistor, signal is transferred from a dash circuit. So these are the options. Okay, in this option, it is a free electrons. And I think this is a explanation with respect to the today presentation. And next part, like the digital circuit, will be explained by our colleague. Do you have any doubt related with the whatever the topic I explained? ಯಾವ್ದಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ನೀವು ಕ್ವಶನ್ ಕೇಳ್ಬೋದು, ಅಥವಾ ನೀವು ಯಾವ್ದಾದ್ರು ಡಿ ಸಿ ಟಿ ಕ್ವಶನ್ ಅಲ್ಲಿ ಅನಲಾಗ್ ಪಾರ್ಟ್ ರಿಲೇಟೆಡ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್ ಪಾರ್ಟ್ ಏನಾದ್ರು ಕ್ವಶನ್ಸ್ ಇದ್ರು ಮತ್ತೆ ನೀವು ರೆಫರ್ ಮಾಡಿರೋಂಥ ಕ್ವಶನ್ಸ್ ಯಾವ್ದಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು. ಯು ಕ್ಯಾನ್ ಅನ್ಮ್ಯೂಟ್ ಅಂಡ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್. I think one student asked upload the class to YouTube. Yeah, I think ಯಾವುದು ಡೌಟ್ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ. ಅವರ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ another staff will continue with the another concept, digital concept. Wait for a minute, you be there in the class only, Google class only. I think madam will start. Yeah, I think the next session, digital electronics, will be start after a few minutes. Now the session will be closed. After the, I think once again it will be intimated. Maybe probably within 5 minutes it will start.